All right, so we're going to jump into Module 7. And Module 7, we're going to talk about exceptions and error handling and then debugging, or not necessarily in that order. All right, exceptions. So within Apex, you've already seen this, but Apex does exception handling. So there's a few keywords that are fairly common in the C language of family of languages. There is the throw keyword, in which we can explicitly throw a particular type of exception. So we might write a method, for instance, and then within there throw, have a statement in which we throw an exception. There's a try, catch, and finally. So the try block is when we attempt to do something. The catch block is if we do throw an exception during the try block, it will then immediately exit out. Then jump down to the catch block, execute the code down there. And then the finally is a place where, regardless of whether we successfully complete the try or if we throw the exception, the finally will always execute. Okay. What is missing, or if you are a Java person, one thing that you don't see is the throws keyword. So in Apex, we do not sort of establish that contract between calling a method that throws an exception with the throws keyword. So it's not what that means at the end of the day, and we've seen this with our DML operations. Surrounding, for instance, our DML operation with the catching or the try catch block for the DML exception is optional. It's not required at any point. So there's not a throws keyword within Apex where we can define that a particular method throws a particular type of exception. Okay. Here's what our exception handling logic looks like. We have our try block, in which we attempt to do something that's risky. Our catch block, in which case if something does happen, we then execute the code there. And then the finally will execute under both circumstances. So, there are a number of different types of exception which extend exception. So there are list exceptions, DML exceptions, math, null pointer, and various other ones. What we do is in your catch, reference the system exceptions by saying that you want to catch a system dot and then whatever the name of that particular exception is. In addition, you can access, there's a number of, the exception class has a number of different standard methods associated with it. I want to point out that there's the get message and the get cause. The get message is intended to be a user-oriented message versus the get cause is more of a intended to be a logging sort of message, so more intended for a technical viewer. The get message would ultimately be returned possibly to the UI versus the get cause would be something would be stored in the log files for a developer to take a look at later. There's a specific type of error that might occur that's called the too many Apex requests error. And what this is referring to is Salesforce has this error which exists where we don't allow beyond a certain point a number of concurrent requests. And it has to do with the fact that even though we apply governor limits from the standpoint of individual transactions, that would still theoretically leave us open to sort of a logged in user denial of service, at least, or denial of database connection attack. Not an attack necessarily, but think about a large number of repeated requests taking place. Like, for instance, if you had something like a load runner or something putting a lot of load on the Salesforce servers where a lot of concurrent requests are coming into the server and they're consuming all of the database connections back to the back-end database. So what this does is it's a different type of limit that's placed on the execution of code, and it's a per org type of limitation. It's all about that a single org cannot have too many concurrent executions of Apex code at any given time. And the entire purpose of this is to prevent a single org from consuming too many database connections, and thus preventing access in that regard. So if you do see it, this is something that support does know about. They have some recommendations for avoiding it, but do keep an eye out for this one. And it's basically it's associated with a too many concurrent requests in which we're executing our Apex code. Excuse me. The DML exception is one of the more popular ones that you'll be working with. A lot of these methods, this is where if we had that save results, we could obtain essentially the row that had the problem and then use that counter or that ith row in order to then get more information about the specific DML exception. So all of these have, or most of them have, an integer argument associated with them, whereby we get the names of the fields. Error message associated with a specific record having a problem, either inserting or updating it within the database. You can create your own custom exceptions. So one of the things that's available is you can create your own custom exception and then extend the exception class. Now, one of the things that you need to do is anytime you create your own custom exception, extend the exception class, and the name of the class that you create must end in the word exception. So it must be something, my custom or, my specific org exception, whatever it may be. It must actually, we have this requirement associated with the naming convention that it must end in the word exception. So you can you can define your own exception, and then here we're just showing that we could throw our exception as a part of the execution of our code somewhere. I think this is kind of a standard thing, but you can have multiple catch blocks, and there's the sort of the fall through, which is to say that you would place the most or the widest exception last and the narrowest exception first. That way, for instance, in this case here we have we're catching the base exception and then we're catching the exception. That way, if it's a base exception, it would fall into the first catch block. If it's anything else, it would fall into the second catch block, because that's the one that defines everything. If we reverse the order of this, the second catch block would never get called because exception would catch everything. All right, so let's take a look at debugging. So debugging allows us debugging is available within Salesforce in kind of two different ways. One is we have our system and debug logs, and then the second is that we have a facility called anonymous blocks, which I've already shown you, which allows us to execute an arbitrary set of code against our system. All right, the system logs and also the debug logs, I'll talk about the difference in a bit. But what this is the logging facility available in the Force.com platform. And when we're writing Apex code, we can write messages to the log files. There's a couple of different places that those messages are written when we do a system.debug. The system log is more of a console. I'll show you where we can access that. And then the debug log is more of a persisted area where we take the message and then write it to the database. All right. You'll also see a lot of default information being written to the debug logs. So in addition to unique messages that you create in the form of doing a system.debug, you will also see a bunch of information associated with things like governor limits. It'll tell you which methods are being called from where, when you're entering into a loop. So there's a lot of default information that you'll see within these debug logs that is in addition to any custom messages that you write. The types of information that you'll see within the system logs and the debug logs are things like when we're doing changes to databases, that could trigger a separate debug log. Automated workflow processes, so any of our declarative business logic features. Validation rules is a separate category. Request response XML, so this is referring to doing callouts from Apex. So anytime we're doing those external callouts to some system via web services. And then our custom script errors that occur, and then the resources used by an Apex script. When we get to the end of this and I do a little demo of the system log and the debug log, you'll see that one of the things that you can do is you can delineate which messages you see in the system log based on different categories, so based on one of these different types. And here are the different types associated with the different types of messages that we would see within the debug logs. In addition, when you select a log category, the different type of thing that you would like to monitor, you can also specify at what level you would like to be seeing the messages. So in this case, this is showing you the different levels that are available for Apex code error messages, but there are there are different sets of levels for different types of categories that we're monitoring. There's a number of places where you can see the system logs. There's really three main places. You can go to the system log within the context of your web browser, going up to the top of the window, clicking on system log. You can also view the debug log under monitoring, and so you can expand monitoring and view the debug logs there. And then the third place you can go is within the Force.com IDE. It has the ability to view the log files as a sort of a listening mechanism. When you're executing your anonymous blocks, it'll dump out all the logging messages associated with that. All right. Like I said, I'm going to save this demo till the end, but the debug logs are a separate area. They are found under Setup and Monitoring. Okay. All right, let's talk about anonymous blocks. Anonymous blocks allow us to execute an arbitrary just set or even a single line of code. So if we think about why do we have anonymous blocks? Well, if you wanted to write a few lines of code and test it out, see what it does, or if you wanted to perhaps insert some data programmatically, well, to create either to create the trigger and then to fire off the trigger, you'd have to create a lot of sort of surrounding infrastructure in order to make that happen. Or if you were creating a custom controller or a custom web service, you'd have to do basically go through a lot more effort than necessary if you just simply wanted to, for instance, instantiate an S object and insert it in a database and see what happens. Okay. All right. So we have anonymous blocks. Anonymous blocks allow us to write that subset of code or a few lines of code and then execute it. Thing to keep in mind about anonymous blocks, it does commit it to the database, so it will get written to the database. So it's not, even though it's it's a little bit misleading in the sense that you have this little window, you can click on the execute anonymous, that will apply those changes to the database. This is equivalent to when you're within our web services API, we have a specific callout called execute anonymous, which will execute a block of code. So it's roughly the same type of facility. We can also execute anonymous blocks through the system log. There's a little facility there. And then we can execute anonymous blocks through the Force.com IDE. Here's what it looks like when we're taking a look at the execute anonymous through the through the system log. So it allows us to, first of all, we can view error messages and we can specify the log category that we'd like to monitor and then the log level. And then we can type in a few lines of code down here in the bottom window at the block and then click on the execute anonymous and that will then execute that code. We can then see the results in terms of messaging in the area above. We can do something very similar within the Force.com ID. There's a tab or a view called Execute Anonymous. This opens up a window where, once again, we have the output area and then the actual code area. One thing that you've probably seen already is in the Force.com ID in the Problems tab, you can see syntax errors, problems with when you compile it up to the servers, problems it runs into. So the Problems tab is, once again, it's also a view for seeing problems with specific lines of code or just problems with your classes in general. All right, testing. So testing is an important part of creating Force.com applications. And the reason is that not only do we recommend that you create unit tests and test your Apex code, but Salesforce actually requires that you create unit tests and test your code. One of the requirements that we have when you deploy code to your production environment is that when we do the deployment to production, we will actually execute your tests and make sure that you have enough coverage before we allow you to complete the deployment. In general, as general guidelines for testing, it's testing, there's always a trade-off in terms of anything you don't test is sort of assumed risk, but the trade-off is that you don't have an infinite amount of time to test every possible condition. So you need to make that decision in terms of what you can test for, and then do as much as you can in terms of predicting what types of problems might happen with your data, create the test code to test that out, and then, like I said, anything else is sort of assumed risk. Within Apex, we have a built-in unit testing framework. And what we can do is we can declare test methods. These are methods that are executed by the system. And what they do is they execute some logic and at the end of the day do not commit any data to the database. So the difference between these test methods and, for that matter, anonymous blocks or anything else you're working on, test methods never commit data to the database. Okay, so if you want to, for instance, insert data, initialize a bunch of data, insert into the database, you can actually select the data that you insert into the database. So during the running of the current context, it's available for you to access and pull down as a part of a SQL query, but it will never be committed to the database. Our test methods are flagged with the test method keyword. They always have a return type of void, and they take no arguments. As I said, they are called by the system, and therefore there's nothing really that we could sort of pass to them. Now, in addition to the test method keyword, which may or may not exist within the same classes as your business logic, there's an annotation called isTest. And what you can do is you can apply the isTest annotation to a class, and this indicates that this class only contains test methods. So the class that contains test methods, what would happen is that once it's annotated with test method, it would contain test methods, and the benefit of using isTest is that we would not count that against the Apex code limits associated with your org. So one of the other limitations that is associated with the Apex code is that there's a 1 megabyte limit for all of the Apex code in your org. Okay. Now, regardless of whether it's a test method or a comment or whatever it may be, any code that you create will count against that 1 megabyte total for your org. Now, if you place the code within a isTest, a class annotated with isTest, that code, those test methods, will not count against those totals. That being said, the feedback I've gotten from, just want to speak to that 1 megabyte limit. The people I've talked to some people in support about this, and for Salesforce's larger customers, some of them have bumped up against that limit. And in contacting, what they've done is those larger customers have contacted support, and support will increase the size of that limit. But they kind of use it as a mechanism to have the customer reach out to us, and then they sort of note that the customer is sort of is executing or has a large amount of Apex code that's currently enabled within their org. So it's not necessarily, my whole point is that it's not necessarily a firm untouchable limit. So when you create test methods, the test methods will be, as I said, called from the system. You cannot directly call test methods. So if you create a test method, you cannot create a class that then explicitly calls your test method. Now that being said, there are a number of ways that you can execute your tests. One of them is that in the Force.com IDE, you can run tests and then run a specific test or run multiple tests. Okay? In addition, you can run tests through the Web Services API. You can also run tests through the web browser, where you can click on a specific class and then run the test associated with that. Good unit tests. So what are our recommendations? Well, good unit tests should cover as many lines as possible. They should execute both sort of your successful paths and also your error paths. So a good test should not only test with good data or good input, it should also test with bad input to test out things like your catch blocks. The requirement that we place in terms of promoting your code to production is that 75% of the lines of your business code must be executed when we run the tests associated with that code. In addition, every trigger must be executed at least once. Okay, so if, let's say, you had 9 triggers, let's say of equal size, and our test code executed 8 of them, even if that came out to be something over 90% coverage, we still need to touch that last one as a part of executing our code. When you're executing your good or your unit tests, they should complete, or they are required when we're applying that rule, to execute without any uncaught exceptions. Okay, so one of the other requirements that we have is that the definition of success is that there are no uncaught exceptions thrown in the execution of your test code. Now, there's uncaught exceptions are one type of error, but you might also have data-oriented errors, and that's where system.assert comes into play. So a system.assert, what you can do is you can essentially create a exception condition by asserting something to be true, and therefore when, for instance, the example I always use is that, very simplistic, but let's say you have a method that takes a number as an argument and multiplies it by 2. Well, what we might want to do is do a assert equals. We would say our input multiplied by 2 equals the return that we get back from calling this method. That way, anytime we pass in a number or an integer, we assume that we're going to get back double whatever we sent in. So that's a very simplistic example, but anytime you have some sort of method that's doing something, you expect to get something back, we would then check to see that our input matches the output, or the expected output matches what we get back. To test out triggers, by the way, just do a DML operation. So the challenge in creating in testing the triggers isn't actually having them execute, it's the marshalling of the test data that's going to have your code do some interesting things. So like I said, make calls using both valid and invalid inputs to whatever your code is. Also test in bulk. So a big mistake that people make is to test using a single record. when you're testing, utilize or test with performing a DML operation where you're passing 20, 30, 100 records, whatever it may be. Okay. It says use the order by and the do not assume that record IDs are in a sequential order. This is just sort of a general rule or a general recommendation for testing, that your tests should either always succeed or always fail. You have to be careful about assuming that there's particular data in the database. And so what you want to avoid is the situation where your test succeeds 90% of the time, but there's some sort of unique condition depending upon which data might be selected in order to change the outcome of your test. So what that means is that for the most part, when you are performing SOQL queries, go out and select the stuff that you just put in there. So create your test data, insert it in the database, and then utilize that as the thing to look up. So even though we never commit the data to the database, it is temporarily in the database during the execution of the tests. There is no, by the way, each test method is limited in context to itself. So each test method is a separate unit of work. Same thing obviously goes for if you had multiple classes that had different tests, those would be separate units of work. So if one test method inserts something into the database, that will not be available for your next test method. There's something called start test and stop test. If you remember back when we were talking about our governor limits, I mentioned that there were three columns for our governor limits. There was the triggers, there was sort of everything else from a business standpoint, which was Visualforce controllers, anonymous blocks, custom web services. And then there was a third column, which was run tests. And so anytime that we're executing test code, what we're doing is we run tests, is calling our code in order to execute the tests. So there's a separate, normally higher level of governor limits that are applied to running unit tests. Now, one of the things, or another thing that you would like to test in your unit tests is to check to make sure that your code is governor limit compliant, right? Now, the way that we can apply the appropriate governor limits for our tests is there's a test class, and what we can do is we can call a method called start test, and then the next significant line of code then determines the context, the governor context, for the execution of our code. So for instance, if the next line of code that I call performs a DML operation, at that point it will apply the trigger governor limits. If I decide maybe I have a Visualforce controller or a custom web service, I could go out and call those methods. It will apply those limits to those executions. Okay? In addition, you might do this multiple times. Therefore, we would need to stop our test. So, for instance, we might test the execution of our code under the trigger governor limits. Then we would stop the test, and then we might call a web service that does something similar to test under that context. Or for that matter, trying different sizes of data, input sizes, or what have you. So the key thing to keep in mind is that test.startTest, the next significant line of code, will determine the context of, that'll essentially, think of that as being the entry point into your code. Okay? So that applies those governor limits. There are a number of ways to execute your unit tests. You can use the Web Services API. There's also some additional methods which are available that you can use. So things like this compile classes or compile triggers, which will actually go out and check to see if your code is valid. One of the things that Salesforce does is we might execute your test code as a part of debugging problems. So one of our purposes with this is that when customers run into problems with their systems, we utilize those test methods to then try and figure out what might be going wrong. Okay? Same thing goes when we're performing an upgrade. we run the unit test to see if we upgrade our customers, will it result in a bunch of errors. So it's a way for us to, before we then roll up to the next version of our system, to do a sanity check to make sure that we're not breaking anything associated with our customers' implementations. Okay. Within the web browser, we can run all tests, and then there's you can click on a specific class and run a specific test. Okay. It'll output a bunch of results. I prefer to use the one within the Force.com ID. That's the one that we're looking at here. It has some nice color-coded stuff where the green light, it indicates, you know, the level of test coverage, and then the yellow warnings indicate the lines of code that were not executed as a part of running the test. You'll also see some red lights indicating that you did not meet the requirement for test coverage in that particular class. So. All right, so let's talk about what we're going to be doing in exercise 7-1. If you remember, yesterday we created our Hello World position class and our Hello World position trigger. What we're going to be doing is creating a test class associated with those two components. Now, the logic in our test class, we're going to perform a DML operation. So we're going to initialize some position data, create a list of positions, then insert those positions into the database. And then the key thing that we're looking for in terms of the execution of our trigger is that the hello world field will be populated, or the hello field will be populated with the string rolled. Okay. So we're going to test to see that that occurs, and then that'll be our test class. Okay. Now the reason that we're doing this is that this is going to be a necessary ingredient for our next topic in Module 8, which is when we get into deployment, we're going to need that 75% coverage in order to get to that next level. Okay. So any questions about this before we get going? Why don't we do I forgot to ask, why don't we do the question answer for if you have any questions about anything I talked about previously.
So when you start a test, what can you assume is in the database? Is it off the same org, or is it some sort of clean org or sandbox? Or?
Mm-hmm. So the question is, when you're executing the test, what sort of assumptions can you make about the database or the state of the org that you're executing the test against? And that's a good good point, because the first place that you're going to be executing your tests are in your developer sandbox typically. So in that case, you might have you probably will have a very small or thin database in terms of the amount of data that you have contained within that. But your code will ultimately be executed against your production database. So it will be executing against your production data. And that's exactly why when we create our tests and we marshal that test data, that we rely on that as opposed to anything that might be within the production environment, because of the fact that you're really going to be testing this under two different conditions: sandboxes and then your production org. So the safest thing to do is to not make any assumptions in terms of what will be there in the database. So often that'll mean not just inserting for instance the current object, but possibly any related objects and creating those types of relationships. Are there any other questions? All right, I've just logged into my org, and let's take a look at some of the debug facilities that are available to us. Okay, within the web browser user interface, the system log can be found at the top of the page, and what I can do is I can click on this link. It'll open up a new window, and from within here, what I can do is monitor different categories of errors that might occur. So for instance, workflow oriented, things like assignment rules and workflow rules, validation rules. Callout is referring to web services callouts, and Apex code referring to things that are occurring, obviously, within my, my Apex code. Apex profiling, by the way, is cumulative profiling information. So this will collect statistics about the performance of your code and then aggregate those numbers. So, in addition, there are different debug log levels that we can execute. So here, none, error, warn, info, debug, and then all the fine ones. So we can monitor at different levels, and there are different levels that are available depending upon what you select. So for instance, for workflow, there's just none, info, and finest. In addition, I can execute anonymous blocks within my system log. So one of the things I could do is write a section of code and then execute that. All right, I'm just going to jump to the debug log. So in my setup area is where I can find my debug logs. They are contained under monitoring, and there's specifically an area called debug logs. Now, debug logs are fundamentally different from system logs. In system logs, you are filtering the error messages that you see based on the type of error or the type of thing that you're monitoring. In the case of the debug logs, it's not category-based, it is user-based. So when you turn on a debug log, you're monitoring for a specific user. Okay? So if I jump out here and I create a new debug log request, what this does is it enables monitoring of anything that that user does. So unlike my system log, which is regardless of the user, monitor these sorts of actions, here it's regardless of the action, monitor anything that this user does. So if I create a debug log, and in my case, here's my user within this system. So if I monitor myself, what happens is that this debug log request is created. Now notice that it says there are 20 requests available. When I create a debug log request, it will log up to 20 actions essentially, or 20 events that occur within my or things that I do as a user. This will increment or decrement down to 0, and then once it gets down to 0, it will churn itself off. In addition, you'll notice that there's a number of different already created logs within here, and this will store at most 20 logs. So this is a list of 20 log files already created at earlier dates. If I were monitoring for multiple users, what it does, or for that matter, if I was monitoring for a user in which there are already logs, much like I have, what it does is it wraps, so the oldest log entry will be dropped from the list and removed from the database. So at any given time, you only see 20 log entries, and at any given log request that you create, it will only capture the first 20 logs. Now that being said, you'll notice that there's a reset link here, and with the reset link, if if you're frequently testing, for instance, within your sandbox, you can keep clicking on that reset to reset that up to 20 more log requests. Okay. So just to show what one of these things looks like, if I go out and let's say that I create, in this case here is my position tab. And if I click on this demo position, in this case, I think that if I, let's see here, if I edit this and I simply, maybe I erase the hello field and click on save. I actually didn't need to erase the hello field, but I did anyways. Now, jumping back to my debug logs, so if I go back here to monitoring debug logs, within here what I see is that my last thing that occurred was in fact my code actually has some asynchronous method calls, but here for instance is some custom error logging that I did within my code, a bunch of system.debug lines, and in my case I dumped out a record ID, I dumped out the name of the record, and then I, using the limits class, I dumped out some governor information associated with the number of SOQL queries I executed. Okay. Other logs will contain greater amounts of information. So this one's pretty sparse. And then in my case, I have a Visualforce page embedded in my standard page layout. Let's see if this one has a little bit more information. So this is one probably associated with the execution of a trigger. In fact, here we go. Here's our hello rolled position trigger. And what this is doing is it dumps out sort of the initial governor limit state. And then, as you'll see, there's a bunch of default debugging associated with different things that are occurring within my code. Starting loops, calling methods, setting variables, so on and so forth. So as you'll see, the debug logs produce a lot of default logging material. In fact, you'll notice here's just showing you the fact that our debug logs, or our triggers, execute one after the other. Here's my hello rolled position trigger, and then I have a position approval trigger that is also firing. Okay. In my preference is the debug logs. It's just easier to catch information because you simply identify the user. Typically, I think what happens when people are debugging in a production environment, if a user has a problem, you would have to have the user recreate the problem or do it again, but first then put on or churn on the debug log request. Okay, so something happens, they send you an email, give you a phone call, you churn on the log request for that user, they then go back in and then do whatever it was that caused the error to occur, and then you can trap any error logging associated with that. In addition, within Eclipse, within the Force.com IDE, there's also a facility for creating, we can execute anonymous blocks. So in this case here, I can go out and create some lines of code. I might do something like here, this is just a very simple system.debug, and I'll type in hello rolled, like so. And then I could also do something like, if I wanted to, I could create a new position, _CP equals new position. Oops, always remember the _C. And then, you know, I'm not going to go through populating this with fields, but I could populate it with test data or something that I'd like to do, and then ultimately perform a DML operation, insert into the database. Okay. But if I then execute these lines of code, in my case, the only thing that dumped out a debug message was my system.debug. And so there it is on the, looks like the third line where it says hello world. Okay. All right. So that's it for the demo for the logging facilities and executing anonymous blocks. All right, I'd like to take a moment to just review our hello rolled position test class that we've been working on, and just take a look at what the kind of stuff that we might be doing in a test class in terms of creating our unit tests. So first off, the first thing that we have is our test method. In this case, it's called hello rolled test. And then notice that we've annotated, or not annotated, we've used the keyword test method associated with this, so that this is, as I said, a method that will be called by the system and will not commit any data to the database. Now, what I did was we created a list of positions that we then would go in and insert into the database. We're iterating, or here we're going to iterate over a list, that list of positions, and then populate each of these positions with a test name, and then make it unique by putting a number on the end and then a test description. One of the things that, one of the requirements associated with our positions was that the job description field was required. So we need to make sure that when we insert this that we have a value there. Then for each of these positions, we've added them to the list. And then finally down here, we have the part of the code where we're going to test our trigger by performing the insert. Now notice what I've done is there's the test.start test. So once again, my next significant statement, that next line of code that does something, in this case performing the insert, that will then fire off my trigger. Therefore, the trigger context will be utilized when doing the governor limits. So here we insert those 21 positions, have a little bit of debug, we turn off the test, and then if we catch a DML exception, we dump that out. Otherwise, continuing the code, after the insert occurs, we go down here and we then select the positions that we would have just inserted into the database. And then we have some assertions about those positions, that they have IDs, that each position that we are iterating through. So here's the test of our logic, which is the hello field is equal to rolled as we set it up in our previous trigger. In addition, there's some other things that we are dumping out there. Okay. So we've tested our trigger. We've done it also for the governor limits. So we're not just testing to see whether or not we are throwing any exceptions, but we're also testing to see that the data that we set has been properly set, and the data that we then query, we get back that rolled field or the hello field populated. Now, if we had a more complex set of code, we probably also would want to then test for any error handling code that we had over in the original that we were calling. So in this case, we had a very simplistic class that we were calling a very simplistic trigger. Okay. If I execute this test now, so one of the things that I can do is within the force.com IDE, I can right-click on my hello rolled test class, and what I can do is go down here to force.com and then select run tests in order to run that test. What's going to happen is that first of all, I have a ton of code out there that's doesn't have any test coverage. Every time I do a class, I end up creating a new trigger or class for some sort of experimental purpose. And so, but down here under the yellow warning sign, at the very bottom here, I can see that some of my code was fully covered. So in the green area, you'll see that there's actually a different trigger called the position approval trigger. But then there's the hello rolled position trigger and the hello rolled position class. And as you can see, they were both 100% covered. Okay. In addition, there's a bunch of debug that's dumped out as a part of this. So the same type of stuff that we would see when we were executing or taking a look at the debug logs or the system logs is being dumped out here so that we can then view any of the system.debug that we are performing. Okay. There's one last thing I'd like to mention about executing tests, which is any calls to system.debug do not count towards that 75% test coverage. So just keep that in mind. That any system.debugs they basically eliminate or remove those as a part of factoring in the 75% number. Basically, as you can imagine, people inserted a bunch of system.debugs in order to reach that 75% number. So they decided that they would turn off that little loophole. So, okay. All right. So why don't we jump into the next lecture topic? And like I said, Tom, I'll take a look at what's happening there because I'd like to see what is, I'd like to see what's going on. Yeah.
So the debug log that you mentioned, the 20 goes away based on the time, or it's going to be there at least the last 20, the most recent 20.
So the question is, when we're taking a look at the debug log, when will it, I guess how long will the logs appear there? Is that correct? Okay. So the logs will appear forever until a new log request is created, and then they will essentially be pushed out in order of oldest to newest in the order that the new requests are logged.
At any point of time, I would have 20. Once I have
Exactly. So anytime, at any point in time after you run those first 20, you will just always see 20 in there. And there's no way to, there's no like clear button. So the delete link that you see next to the request is to stop future requests coming in from creating logs. But there's no real way to go out here and to clear out the logs that you see. Okay. It's a little bit confusing because the maximum number of log requests is 20, but it's also the number of entries that are stored there. So it's not until you set up 2 users and then both those users are doing things that you see that, it's really, you'll see both of them do all their requests, and then you'll only see the last 20, regardless of if one person had the last 13 and the other person had the last 7. It's only the last 20 that were performed that will appear in that list. Okay. All right. So let's jump into our next topic, which will be the deployment. So let's first do our module review associated with testing and debugging. So what are the Apex keywords that are used in handling exceptions, and what would the typical layout be for those keywords? So the answer to this one is that there's 4 words. There's throw, try, catch, and finally. And then the order in which they would appear in a typical layout for exception handling is try, catch, and finally. List 3 system exceptions. 3 of the types of exceptions that we might see are list exceptions, DML exceptions, string exceptions. So there's many others, math, null pointer, so on and so forth. Where can you view the system log? So on the browser web page, there is the system log at the top of the page, and then also within the Force.com IDE. What are the 2 criteria that can filter the amount and type of information displayed in the system log? So the category, the log category, and then the log level. Okay. Why use anonymous blocks? You can either test out an arbitrary set of code, or another purpose is you want to insert some data for some purpose into the database. You can fairly easily do that using an anonymous block. So. How can you tell a method is a unit test method? So test method, void return type, so no arguments. Those are all the things that identified our test methods. Very good. Let's see here. Where can you run unit tests? So through the IDE, going over to develop Apex classes within the setup menu, clicking on one of the buttons there. There's actually a third one. Do you remember the third one? Does anyone remember the third one? You can actually do it through the Web Services API. So you can execute test methods remotely using the Web Services method, or using a Web Services call. Okay, very good. All right.
For more information on Salesforce.com training and certification, please visit www.salesforce.com/training.